Hello friends, welcome to our channel Mission Critical. Here is a continuation of our video series called Engineering Teaching with the new subject today, Discrete Time Signal Processing. This subject is advanced part in the signals and processing systems. This deals with discrete time signals, converting them from time domain to frequency domain. Before moving on to the teaching part, I would like to make sure you people know that this is an exam-oriented video. This video is developed for specially students belonging to the University of Mumbai in the branch of EXTC and electronics. Now moving ahead with the teaching part, this is the basic formula which represents how a time domain signal gets transformed with any limit and gets converted into a frequency domain. Now, including this, we will be requiring a few formulas which will be displayed on your screen now for a few seconds. Pause it, write it, will be required throughout the video. For the first topic today, we will begin with the LTI system. These are the steps that we have to be performing according to the questions asked. We will be first converting the LTI into frequency domain, and then we'll be finding frequency response of the system, impulse response, and then finally magnitude response, and then identifying the filter. So now consider this LTI system as an example. This is in time domain. The first step will be converting this into frequency domain. For that, we will be using Z transform. The formulas required to do so are given in the photos you saw previously. So the transformed function will be something like this. Now simplifying this, taking x of z common throughout. So after this, we will be taking h of z, which is y of z upon x of z. Keep in mind guys, every time we solve any sum in this subject, h of z is the important thing. If we have anything in the time domain, convert them first in frequency domain, simplify it and find h of z, or in most of the cases it will be directly given. So our h of z is 1 plus 2 z inverse plus z raised to minus 2. This is the first thing that we have done. So the first step now is finding out the frequency response of the system. This is very easy to do. Just we have to replace the z terms with e raised to j omega. This is how we get the frequency response of the system. So guys, this is how we find frequency response of a system that has been freshly converted into frequency domain. So guys, this is how we find frequency response of a system. So the next thing we will be doing is impulse response. So delta function says that delta function of any natural number that is not equal to 0 is always 0, and delta of 0 is always 1. I'll repeat again. Delta function of any natural number which is not a 0 is 0, but delta function of a 0 is equals to always 1. Now beginning with impulse response. In impulse response, we do not take equation which is in frequency domain, we take the equation which was in time domain. Now replacing the y terms with h and x term with delta. In this equation, the n value is unknown, so we have to take n values as natural numbers beginning from 0. The preferred value is up to 3 to keep the sum as simple as possible. So now taking initial value as 0. So h of 0 will be delta 0 plus twice of delta 0 minus 1 plus delta 0 minus 2, which will give us, this is already been told before, this will be directly 1, this will be minus 1, this will be minus 2. and as delta function says, delta of any number other than 0 will be 0. So 1 plus 0 plus 0 will give us h of 0 equals to 1. Similarly, we have to do this all for 1 and 2, and 3 is the maximum, I guess. Now, as we solve for h of 0, we similarly solve it for h of 1 and h of 2, where the values we get is 1, 2 and 1. Now, we have to plot these, which is very simple. This is the x-axis. This is our position 0, this is 1, this is 2. For 0 we have value 1. At 1 we have value 2. And at 2 we have value 1. That's it. That is impulse response. So now coming to the third part, that is magnitude response and identifying the filter. For this, the solution of the frequency response is where we begin. In this, do you see this part? E raised to j omega. We have to expand this part with this formula. That's the basic trigonometric formula. This is how it looks when we expand the formula. After simplifying this, we separate the real terms on the left and imaginary terms on the right, which will give us the equation in the form of a minus jb, where a will be the real part and b will be the imaginary part. After we are done with finding the simplicity of that equation in the form of a minus jb, we will be required to find the magnitude of it, which will be like this: square root of a square plus b square. Remember guys, it will be always plus here, whatever we get in this, either it will be minus or plus. Usually it will be minus, but whatever the case here is, this will be plus forever. So after simplifying the formula, we find that we have an unknown term omega, and we cannot move forward until we know the fixed value of this. So for this, we have three different values of omega. That will be 0, pi by 2 and pi. So we have to find all the three possible values of magnitude response, with omega being 0, pi by 2 and pi. After further solving it, we get the value of omega at 0 is 4, omega at pi by 2 is 2 and omega at pi is 0. Now after finding all the three values, we will be using these three values to identify which type of filter we are using. Let me show you how. To identify which filter we are using, first we need to plot these on a plane graph. You do not need a professional graph to do this. You can simply do it on a piece of paper or in a corner of your paper. This will be 0, this will be pi by 2 and this will be pi. At 0 we have 4, at pi by 2 we have 2 and at pi we have 0. So we get a straight line like this. To identify which filter we are using, we have to observe the value of pi and 0. As you can see in the plot, the maximum value always passes through pi. So the pi value here is 0, that means it is the least, and 0 value is highest. That signifies that this is a low pass filter. Similarly, for a high pass filter, we need the conditions to be like this, where the pi value is highest and the 0 value is the lowest. For an all pass filter, all the values will be same. So these two are the most commonly expected questions in exam for LTI, and I'll be solving only one today. The second one's solution will be given to you at the end of the video. So now we have been given the parameters in time domain. We have to convert this first in frequency domain using the formula h of z equals to, since we only have two values with value position number 0 and 1, we have taken limits 0 and 1. Remember guys, the number of values we have, minus 1 from them, and we will get the position number of the values. These things matters, that is 0, 1, whatever the further values will be, that will be 2, 3, all that, etc. So we have only 2 values, that will be 0 to 1, so the limits will be 0 to 1. H of n z raised to minus n. So further solving it, h of 0 z raised to 0 plus h of 1 z raised to minus 1. We get h of z as 1 minus 1 upon 2 z inverse. So now first thing will be frequency response. That is z equals to e raised to j omega. So the frequency response will be h of e raised to j omega equals to 1 minus 1 by 2 e raised to j omega. Now the magnitude response and the identification of the filter. We have h of e raised to j omega equals to 1 minus half z inverse, which will be 1 minus 1 by 2 cos omega minus j sin omega. This will give us 1 minus 1 by 2 cos omega plus j half sin omega, where this is the real part and this is the imaginary part. So now the magnitude response. We get as 0.5 for omega equals to 0, 1.1 for omega equals to pi by 2, and 1.5 for omega equals to pi. So now with the omega values in front of us, we can start plotting. The 0 value is 0.5, the pi by 2 value is 1.1, and the pi by 2 value is 1.1, and the pi value is 1.5. So since the pi value is higher and 0 value is lower, we can say that this filter is a high pass filter. Now since the equation given to us is in time domain but without any variables like x or y, we didn't do the impulse response. Now for the second example, the solution will be on your screen.